Hey everyone, welcome to another AP Calculus video. Today we're going to review something called the Sandwich Theorem for finding limits. And what the Sandwich Theorem says is that if I have a function whose limit I can't find, and I want to know if a function converges or diverges or if a limit exists, and we're talking about this specifically with regard to sequences, which is a list of numbers. So when I have a sequence or a list of numbers and I want to know, are the numbers approaching something? Does the limit exist? One of the tools that I can use is something called the Sandwich Theorem. And the Sandwich Theorem is a wonderful tool for things that involve trig functions, things that oscillate back and forth, things that I know are going to be between a set value and another set value. Because the idea is, if I know that my function exists between these two values, like for example, sines and cosines always exist between 1 and -1 in general. And so if I know that I have a function that will always be trapped between two functions, what I can do is I can say, well, if the limit of this function is like 0 and the limit of this other function is also 0, and I know that my cosine is trapped between them, what they do is they sandwich my function in and they force it to have the same limit. So basically I'm taking a function that's both above and a second function that's below, and I'm saying, well, they both have the same limit, therefore my function must also have the same limit, because we're constantly sandwiched between. So think of it this way, like the bread in your sandwich are the two functions you choose. So you're going to choose the type of bread. You're going to choose the two equations to sandwich your function in. Your function from the problem is like the meat and the good stuff inside the sandwich. So let's take a look. Here's what it actually says. If the limit as n approaches infinity of a sub n is equal to the limit as n approaches infinity of c sub n. Now remember, we're talking about sequences. So an and cn are two different sequences of numbers. So for example, maybe you have a sequence, a list of numbers that's approaching 0. And then you have another list of numbers that's also approaching 0. And term by term by term, you then have a third sequence, which we're going to call b sub n, where each of the terms is always sandwiched between the a and the c. Well, then what happens is if a and c both have the same limit, then the one in the middle must also have the same limit. That's essentially what the Sandwich Theorem says. So we have to get a little creative when we're picking our values. So let's take a look. Does a sub n equal cosine of n? Now, just because I call it a sub n, that's not the same as the one in the definition. So this is a definition. Okay, definition. So if I want to know if this converges, I'm going to remember that I always want to make sure that I pick a function, or I want to apply this Sandwich Theorem when I have a function that oscillates, like sine or cosine, or there's other examples that are going to be trapped. But I know that cosine is always going to be between -1 and 1. So I'm going to say that. I'm going to say, hey, I'm using the Sandwich Theorem. I need to prove why I'm able to make the claim. So I'm making an argument, right? So I'm like the lawyer. We're in the court of law. Does it converge? Well, since cosine is always between -1 and 1, okay, so I need to state that. And, oh, well, I guess I don't really need to say any and. But since this is true, we can also then say that -1 over n, we're just going to take each of these terms and set it up like that. We're going to say, well, hey, since the numerator is always between -1 and 1, we know that this function will be between -1 over n and 1 over n. So what we're doing is we're setting ourselves up here. Now, what we're going to do is we're going to do the limit of this guy. So the limit as n approaches infinity of -1 over n is 0. Okay. Then we're going to do this guy. The limit as n approaches infinity of 1 over n, positive 1 over n, is also 0. So we're going to demonstrate that the two outer functions both go to the same number. Because I'm sandwiched between them, because their limits are the same, they must also then force my function, which must stay between them. And since they're both going to 0, mine gets sandwiched in between. Therefore, the limit of cosine of n over n as n approaches infinity is also 0. Ta-da! That's really what we use. That's the sandwich theorem. We have to be a little more creative about picking a function that is the bread, the outer pieces. And it really works best when you know you have a function that will always oscillate between two values. So hopefully this is a good little overview of the sandwich theorem. It doesn't happen very often. It's also called the Squeeze Theorem, by the way, aka Squeeze Theorem. Because we're squeezing our function's limit down to 0 in this case. So hopefully this is helpful. It is one that requires some creative thought. You're not going to be able to use it on every example to prove that a limit exists, but you can use it from time to time, and it's one of those topics that does make its way onto the AP exam from time to time. So look for opportunities to put it into play. Think about, what functions, especially when I have a sine or a cosine, can I use the squeeze theorem to trap it between two functions, or the sandwich theorem to trap it between the bread. The more you practice with it, the more you look for opportunities to use it successfully, the more comfortable you're going to get with using it. So keep at it, keep practicing. You can do this. You've got this.